Hello, I welcome you all to this wonderful and exciting video. Here we're going to be looking at the atomic structure. Okay, so the atomic structure actually looks at the diagrammatic representation of an atom. Okay, so it's a very interesting topic. So an atom, it is defined as the smallest particle of an element, okay, that can take part in a reaction. So this whole thing you're looking at again is an atom. Now you have something at the center here. You have what we call the sub. Okay, you have what we call sub. Okay, subatomic. Okay, you have subatomic particles. So these subatomic particles are found at the center here. So you have the atom, but then this atom is the smallest particle in an element, but then it has other smaller particles that we call subatomic particles. So the subatomic particles are found at the center here. Okay, at the center here. So now this center here, it is called the nucleus. Okay, it is called the nucleus of the atom. Okay, so the center is called the nucleus, and then you have these concentric rings. These are called, actually we just call them the shells. Okay, so we can just say these are the shells in this particular atom. Okay, these are the shells. Now in these shells you can see these green substances or particles. Again, these also are subatomic particles, but these subatomic particles are not found at the center, they are found on the shells, and these ones we call them electrons. Okay, we call them electrons. Okay, we call these electrons. Okay, so these are called electrons. Okay, now at the center here, you're going to find something interesting here. Okay, you're going to find something interesting, and what we find here is that these ones which are orange, okay, the ones that are orange, these that are colored orange, these are actually called, we call them neutrons. We're going to look at why do we call them neutrons. Okay, so just to keep it simple and to raise your curiosity, they're called neutrons because of this. Okay, neutral. Okay, so they're called neutrons because we're going to talk about something neutral. Okay, we're going to talk about something neutral. That's why we call them neutrons. Okay, neutral. So neutrons from the word neutral. These electrons from the word electricity, something like that. Okay, you think of them like that. Okay, and this is a very important thing. As you go in detail, you're going to learn a lot of things. Okay, so the ones that are positively charged and in blue, these have got a special name. We call these ones protons. Okay, we call these protons. Okay, call them protons. So now these that I'm going to underline with this marking, these ones, these, as well as these are part of the what? The subatomic. Okay, the subatomic particles, and the whole thing now all together is called the atom. Okay, it's called the atom. All right, so it's called the atom. So now that we've looked at these, okay, so you have three subatomic particles and you have got shell. So this is a shell, also this one is a shell, and this whole thing here, okay, it's called the nucleus. Okay, so the nucleus is made up of, we can put it like this. We can just say that when you get the whole thing, okay, what this thing actually is, the whole thing now all together, we call it the nucleus. Okay, it is called the nucleus. Okay, so this is the nucleus. So the atom is made up of two important things, the nucleus and the shells. But the nucleus has got two subatomic particles. One of them are what? Protons. They are found in the nucleus. Protons. And what else? Neutrons. Okay, neutrons. Sorry about that. They're called neutrons. Okay, so these two are found at the center here. So the protons, as you can see, they have a charge, a positive charge, but the neutrons, they don't have any charge. In other words, the neutrons are neutral. That is why I said they are called neutrons, because they are neutral, having no charge. Okay, electrons are charged. Okay, and electrons are found within the shell. As you can see, they are found within the shell. Okay, now these shells, okay, these shells are also called, okay, the shells are also called energy levels. Okay, the shells are also called energy levels. Okay, this is energy level 1, energy level 2, they go on and on. Okay, so they're also called energy levels. So these electrons, you can see that some electron, like this electron here, is found in energy level 1. Now we give them names like maybe the first one is called L, okay, and the second one will be called M, and the other one will be called N. Okay, then the other one O. So they start from L, M, N as you follow the alphabetical order. So the first shell here is called L. Okay, so the first shell, so you have these shells. So the first shell, we are saying the first shell is denoted by the letter L, and the second shell will carry M. So as you go on, the third shell will carry N or P, just like that, and so on and so forth. So you have these energy levels, these concentric rings that are surrounding. Okay, so now these are subatomic particles. We've said we have the protons, and you have the neutrons, and you have the electrons. They are subatomic particles. So now you have to look at them in terms of the charges, okay, which we've already discussed. These guys, you can see these are negative. Okay, so these are actually negatively charged. Okay, these are negative, they've got negative charges. Okay, but these are positive, these are positively charged. But these, like I said, neutrons, neutral, they have no charge at all. They have no charge. Okay, they have no charge. Okay, they are actually neutral. Now the other thing we should know apart from this is that these protons, they have a mass. Okay, when they measured the mass was actually found to be 1. We measure them in atomic mass unit. Okay, so AMU. Okay, 1 atomic mass unit. Also the mass for the neutron was also measured scientifically, was found to be 1, okay, atomic mass unit. Okay, now interestingly, the other subatomic particle, which are the electron, it was discovered that the mass for this electron is actually very small, about 8,000 and approximately 75. When you divide that number, it will give you 0.000 until you get these numbers. Okay, so you'll find that the mass for this electron is very small, about 0.00 something. Okay, so it has a very small mass. So because of that, we say the whole mass of the atom is concentrated just here at the center, which is the what? The nucleus. Okay, just there at the center where the nucleus is. Okay, where the nucleus is, that is where the whole mass is actually concentrated. Okay, so the whole mass is concentrated. So now what have we learned? We've said the atomic structure is like this. It has got shells that we call energy levels, and they start from L, M, okay, and so on and so forth. And within these shells you have electrons that are negatively charged with a mass, a negligible mass, which is about 1/8.75. Okay, and these are found within the shells. And then inside now the nucleus, you've got two subatomic particles, protons and neutrons. Protons are positively charged. Okay, they have this plus charge, these no charge, so the charge is 0, and so on and so forth. Then you have these. Okay, so this is what we've looked at in this video. Okay, so now to go a bit further under atomic structure here, okay, you find that there are important things you need to know. Okay, so in an atom, you find that within the atom, when an atom is neutral, the whole atom must be neutral. Okay, what do we mean when the whole atom is neutral? When something is neutral, it simply means that the positive charges, okay, I want you to understand this, are equal to the negative charges. When the positive charges are equal to the negative charges, it simply means that the the atom will be what? Will be neutral, meaning the charges will cancel out each other. They'll cancel out each other. Okay, so for instance, let's look at the element carbon, just for illustration. The element carbon, when you go on the periodic table, find that carbon is given this symbol with the 6 down and a 12 on top. Okay, so now the number which is down here, very important. So the number which is on top is the mass, the number which is down is the proton number, okay. So now remember, the protons are positive. Okay, so the protons are positive. So when we say that there is a 6 down, we're saying it has actually 6 protons, right? So the positively charged here are actually 6, so you have plus 6. The negatively charges, so now here is where I want to explain. For a neutral atom, the number of protons is equal to the number of electrons, because electrons are negatively charged. Okay, so the negative ones are electrons. Okay, so we can say that for a neutral atom, okay, you can say the number of protons is basically equal to the number of electrons. Okay, to the number of electrons. So in this case, whenever you see something like this and you're asked for the proton, you just say, you take the number which is down. So the protons are 6. Okay, but since it's an atom, automatically you know that the electrons are also 6. Then how do you find now these other guys, the ones which are neutral? you always subtract. So the mass number is given by the letter A and the atomic number is given by the letter Z. So to find the number of neutron, you simply say A minus Z. A is what? The mass number. So the mass number is 12 minus the proton number is 6. So the number of neutron is also 6. So we say the number of neutron is also what? 6. Okay, that is how you can get some of these things. Okay, so I hope you have an idea now about the structure of an atom and what is really happening. Okay, we'll go much further in a bit detailed in our next video, but just before we end this video, let's look at something interesting. Okay, so let's look at this atom here. So these are called nuclides, and they're also representation of atoms. So for example, this is sodium. Okay, when you go on the periodic table, you are going to find this. This is sodium. So you find that sodium, it's written as Na. Natrium, the English is sodium. So this is the mass number. Okay, that's the mass number here. We call it A. Write that nicely. Okay, so this one we call it A. So this is called the mass number. Sometimes they call it the nucleon. Okay, I'm not going into details why, but nucleon because the mass number appears at the nucleus, so it's called nucleon from nucleus. Then this one is called Z, and it is called atomic number. Atomic number. Okay, atomic number or proton number. Okay, or proton number. Okay, so just by looking at this here, if you wanted to count the number of protons, okay, the number of protons in this structure will simply be 11. The number of we're looking at the subatomic particles, so protons, we've said the 11, you just get the number which is here. Electrons, you get the same number here. We said electrons are equal to protons in a neutral atom, so electrons will also be 11. Okay, so this is electrons. And then neutrons, you always subtract this minus this. So if you do 23 minus 11, you get what? 12. So in this particular case, you find that the neutrons are actually 12. Okay, the neutrons are actually 12. Okay, so this is how you can actually show these. Okay, so now let's go in a bit detail away from this. All right, so now how do we show these electrons? Okay, we are saying it has 11 electrons. This number is the proton number, but again it is also equal to the number of electrons. Okay, so now this leads us to what we call the electronic configuration. Okay, so now we said that these shells, the electrons are found within the shells. Okay, so we said the electrons are found within the what? The electrons are found within the shells. Now how do these 11 electrons fit in the shells? So we said, remember that these shells, you have got the first shell L, the next shell M, the next shell O. Sorry, it's after M, it's N, M, okay, and then O. All right, so how do this? So now, according to this, is called the first shell, the first energy level. Okay, then this is the second shell. This is the third shell. And that will be the fourth shell. So looking at sodium here, once you just see that the number down is 11, it has got 11 electrons. I want you to follow this. If you are learning this for the first time, it has 11 electrons. So now these 11 electrons, the way you put them in the shells is like this. So according to the rule, or what we call the octet rule, states that the, let me just write that so that you, if you want to Google them to learn further. So the octet rule, we'll look at that. So the first shell can occupy a maximum of only 2 electrons. The second shell can occupy a maximum of 8 electrons. Okay, and the third shell can go as up to, should be 18. We use this formula, 2 to the power n squared. So n is the shell number. So shell number 1, so you do 2, put a 1 for n because that's the first shell. 1 squared, that is 1. 1 by 2, that's how you get these 2 here. And then in the second shell, you put 2 and then squared. So 2 squared, that will be 4. 4 by 2, 8. In the third shell, you now put 3 here. 3 squared. 3 squared is 9. 9 by 2, 18. Yeah, so 18. So this is the formula that we use. 2 squared is equal to 2n squared. So the first shell can occupy a maximum of 2 electrons. So out of these 11 electrons, let's see how many can go in. So we're going to put, so we can show electrons either in a dot or in a cross like this. So that's an electron. We can put another one there. So these 2 electrons have gone in the first shell. Okay, now remember, out of the 11, 2, we've put them in the first shell. How many are remaining? So that will be 9. So you have 9 electrons now remaining. So the second shell can occupy 8. So out of these 9, 8 can go into the second shell. Okay, so you put them in pairs. When they are more than, when they are 8 and above, you put them in pairs. So 2 can go there, the other 2 there. Okay, so that is 1 2 3 4. The other 2 here, that will be 6, and the other 2 there, this will be 8. So 2 4 6 8. Now remember, there is one more electron remaining. Okay, there's one more electron remaining. If we count, this is 8 8 9 10. There should be 11. So this will make us, now we need to have another another shell. Okay, we need another shell. Here's what we are going to do. We are going to make another shell. Just do this. Delete this, isn't nice. Okay, then we do this. I think this is better. Okay, so this will be now the last shell. Now this last shell is one that is going to occupy the last electron. You can put it anywhere you feel like. So when you count the number of electrons, there should be 1 2 3 4 5 6 7 8 9 10 11, and that is how you actually put these electrons inside this. So this is how the sodium atom actually looks like. Okay, now we've shown how it actually looks like, but the protons, you don't need to actually show the protons and the electrons. You just know that they are what at the center here, and the number which is down gives you the number of protons. To find the number of neutrons, just subtract. Okay, let's do another one so that you can follow it nicely. Okay, so let's look at magnesium. So magnesium, from the periodic table, you can see it has 24 on top, and down there 12. So quickly, the number of protons, there are 12. Then electrons, remember, electrons, number of electrons equal to what? Number of protons, isn't it? So 12 as well. Then the number of neutrons, you subtract this with this, but unfortunately this is also 12, or fortunately it's also 12. So this is what you have now. So how do you show now these? We know this is the mass. How do you show now these are the other ones? Okay, so what you do now, okay, so I've drawn 3 shells here. Let's try to put these electrons there. So the first shell, if you remember, we have shell 1, 2, N. Oh, this is shell number 1, shell number 2, 3, and the 4th shell. Okay, so from the 12 electrons, so the electrons are 12. Okay, so the first shell can occupy 2. The second shell, according to the octet rule, can go up to 8. Okay, now how many electrons are remaining? So 2 plus 10, or 2 plus 8, that is 10. 12 minus 10, so you only have 2 electrons left, and these 2 electrons that are left, you can just put them in the third shell. This is occupied to maximum, it can't go beyond 8, so the 2 electrons will go there. Okay, so you're going to show them like this. Then the 8, when they are 8, you can always pair them. Then the other 2 that were remaining, you can put them like this as well. So there are 12 altogether. Okay, so I hope you've learned something. That's how you can show atomic structures of different types of atoms.